Calculate the voltage across 6 ohm resistor using source transformation, nodal analysis and mesh analysis. Here in this circuit, we have to find the voltage across this 6 ohm resistor by using source transformation, then by using nodal analysis and by using mesh analysis. Solution. So let's solve this circuit first of all by using source transformation. So number 1, by using source transformation. So let's solve this circuit by using source transformation. Now first of all, let's convert this voltage source and this voltage source into its equivalent current source. So let's convert it. Now here we can see this resistor and this resistor are currently connected in series with this voltage source and with this voltage source respectively. So let's convert this voltage resistor into series resistor into parallel resistor. So it will be like this, and its value will be 10 ohm, and here this voltage source will be converted into its equivalent current source, and the polarity of this voltage source is like this: positive upward and negative downward. So here the equivalent current source will be on upper side and its value will be, first of all we will erase this resistor also to avoid confusion. Now its value will be I is equal to V upon R. So the value of voltage is 6 volt divided by resistance value is 10 ohm. So 6 divided by 10. So it will be 6 divided by 10 is 0.6. So it is 0.6 ampere. Now we will convert this voltage source into its equivalent current source. So first of all we will erase this 8 ohm and convert it into parallel. So it will be of 8 ohm. And now we will convert this 4 volt voltage source into its equivalent current source. So it will be like this. Now here also I is equal to V upon R. The value of voltage is 4 volt and the value of resistance is 8 ohm. So it will be 1 by 2. That means it is 0.5 ampere. It is 0.5 ampere. Now here we have to find the voltage across this 6 ohm. So we will keep this as it is and we will simplify the remaining circuit. So let's redraw the circuit. Let's copy this circuit from here. Now here we can see the direction of this current and this current is same. So we have to add them. So it will be 0.5 plus 0.6. So 0.5 plus 0.6 will be 1.1. So here this current source will be 1.1 ampere. Here we can see both the current source have the same direction, that is upward. So they will get added. Now this 10 ohm and this 8 ohm are connected in parallel. So 10 ohm parallel with 8 ohm. If we simplify this, so it will be 10 multiplied by 8 divided by 10 plus 8. So 10 multiplied by 8 divided by 10 plus 8. So it is 4.44 ohm. So let's erase this resistor and make it single resistor. or we can redraw this. Let's copy this and again let's erase this 10 ohm and it will be of single resistor of 4.44 ohm. So it will be of 4.44 ohm. Now next, here we have to find the current through this 6 ohm resistor. So we can find this by using current division rule. Let's say this current is current I 6 ohm. So by using current division rule, so it will be I 6 ohm is equal to this current, that is 1.1 ampere, multiplied by opposite branch resistance, that is this 4.44 divided by total, that is 4.44 plus 6, 4.44 plus 6. Now if we solve this, so we get 1.1 multiplied by 4.44 divided by 4.44 plus 6. So it is 0.467 ampere. So this is the value of current I 6 ohm. But we have to find the voltage across this 6 ohm. So the voltage across 6 ohm will be, let's say it is V6 ohm. So it will be current, that is I 6 ohm multiplied by the value of resistance. The value of resistance is 6. So it will be 0.467 multiplied by 6. So if we solve this, so we get 0.467 multiplied by 6. So it is 2.802. And since it is a voltage, so its unit will be volt. So this is the value of V6 ohm. So this is the answer by using source transformation technique. Now next is we have to find this by using nodal analysis method. So by using nodal analysis, let's copy this circuit again. Now solution number 2. By using nodal analysis. So by using nodal analysis, let's solve this circuit. Now let's say it is a node with voltage VA. So let's say it is a node A and with voltage VA, and let's say this is a reference node or ground node with 0 voltage, and let's say this current is current I1, this current is current I2, and this current is current I3. All the currents are towards this reference node. Now let's apply KCL at this node. For nodal analysis, we have to apply KCL. So apply KCL at node VA. KCL stands for Kirchhoff's current law. KCL stands for Kirchhoff's current law, and it is summation of all the current entering a node is equal to summation of all the currents leaving the node. So here the entering current is I1. So I1 is equal to leaving currents. Now leaving currents are I2 and I3. So I2 plus I3. This will be I2 plus I3. Now this I1 is 6 volt minus VA divided by 10. 6 minus VA divided by 10 is equal to I2. Now this I2 is VA minus 0 divided by 6. VA minus 0 divided by 6 plus I3. Now I3 is VA minus 4. VA minus 4 divided by 8. Now let's simplify this. So it will be 6 by 10. 6 divided by 10 minus VA by 10 is equal to VA by 6 VA by 6, then plus VA by 8, then minus 4 by 8. VA by 6, then plus VA by 8, then minus 4 by 8. So let's simplify this again. So it will be 6 by 10 minus VA by 10 is equal to, now this will be 1 by 6. If we take this on left side, so it will be minus VA by 6, then plus, now again this will be minus VA by 8. Then this will be, if we take this on left side, so it will be plus 4 by 8. 4 by 8 is equal to 0. So let's simplify this VA terms. So VA in bracket, now this will be minus 1 by 10 minus 1 by 10 minus 1 by 6, then minus 1 by 8. So it will be minus 47 by 120. Minus 47 by 120. Then if we solve this, 6 by 10 plus 4 by 8. 6 by 10 plus 4 by 8. So it is 1.1. So it will be plus 1.1 is equal to 0. If we take this on right side, so it will be like this. VA minus 47 by 120 is equal to minus 1.1. So VA is equal to minus, this minus and this minus will get plus. So 1.1 multiplied by 120. 1.1 multiplied by 120 divided by 47. So it will be 1.1 multiplied by 120 divided by 47. So it is 2.80. 2.80. This is the value of VA. So VA is equal to 2.80, and since it is a voltage, so its unit will be volts. So it will be volt, and VA is nothing but the voltage across this 6 ohm. So therefore we can write V6 ohm is equal to 2.80 volt. So this is the answer. By using nodal analysis, we can check the same answer we got by using source transformation. Now let's solve this by using mesh analysis. So again, let's copy this circuit from here. And now we will solve this by using mesh analysis. So number 3, using mesh analysis. Using mesh analysis, we will solve this circuit. Now here we can see there are total 2 meshes. Let's say this is mesh number 1 with current I1, and this is mesh number 2 with current I2. We have to take the direction of both the current same, that is clockwise, or we can either take this current counterclockwise, then we have to take this current also counterclockwise. Now let's assign the sign. So according to the direction of this current I1, this will be positive, negative, positive, negative, positive, negative, positive, negative. Now here, let's start from here. Apply KVL to mesh number 1. Let's apply KVL to mesh number 1. We will start from this point. So it will be minus 6, and this will be plus 10 I1, plus 10 I1, then plus 6, it will be I1 minus I2. So I1 minus I2 is equal to 0. So it will be minus 6, then plus 10 I1 plus 6 I1 minus 6 I2 is equal to 0. So let's solve this. It will be 16, 10 plus 6, 16 I1, then minus 6I2 is equal to, this will be plus 6. Now let's say this is equation number 1. Now apply KVL to mesh number 2. Apply KVL to mesh number 2. So if we apply KVL to mesh 2, let's start from this point. It will be plus 6 in bracket I2 minus I1. I2 minus I1, then plus 8I2 plus 8I2, then plus 4 is equal to 0. Plus 4 is equal to 0. So this will be 6I2 minus 6I1 plus 8I2. We can write is equal to minus 4. Now let's write I1 terms first. So it will be minus 6I1, and this will be 6 plus 8. So it will be plus 14 I2 is equal to minus 4. Let's say this is equation number 2. Now solving equation 1 and 2, we get, if we solve equation 1 and 2, we can directly solve this in calculator. So it will be shift mode, then 5, then there are two unknowns I1 and I2, so equation number 1. So it will be 16, then minus 6, then 6, then from equation 2 it will be minus 6, so minus 6, then 14 minus 4. So I1 is equal to 0.319. 0.319 ampere is the value of I1, and I2 is equal to minus 0.148, minus 0.148 ampere. This is the value of I2. But we have to find the voltage across this 6 ohm. So we have to find voltage across this 6 ohm. First of all, we need to find the current through this 6 ohm. So this I1 is moving clockwise and this I2 is also moving clockwise. Now which one is greater? Here we can see both are in opposite direction, that is I1 and I2 are in opposite direction. And here we can see I1 is greater than I2. So therefore I6 ohm, the current through 6 ohm will be I1 minus I2. We are taking I1 here because I1 is greater than I2, and we are subtracting it because both I1 and I2 are in opposite direction. And here we are writing I2 because I2 is smaller. So let's simplify this. So it will be 0.319 minus I2. I2 is minus 0.148. So it will be, if we solve this, it will be 0.319 minus 0.148. So it is 0.467. 0.467 ampere is the value of I6 ohm. And we have to find voltage across this 6 ohm. And here we can see the direction of this I1 is, here we can see the direction of I1 is downward. So it will be downward. So that's why the resulting current will be also downward, because the leading current, that is the greater current, is downward. That's why this current will also be downward. Now we have to find V6 ohm, voltage across 6 ohm. So it will be V6 ohm is equal to I6 ohm multiplied by the value of resistance is 6. So it will be 0.467 multiplied by 6. So 0.467 multiplied by 6. So it is 2.802. 2.802 is the value of V6 ohm. So this is the voltage. So its unit will be volts. So this is the voltage we got by using mesh analysis. So we got the same answer by using nodal analysis and by using source transformation. So this is how we can solve the question by using source transformation and nodal analysis and by using mesh analysis. Check out the link in the description below. There you will find thousands of questions and answers and videos related to electrical and electronics engineering. Also, check the affiliate links in the description below. Thanks for watching.